So we're going to look at more dilations today, but instead of being centered at the origin, we're going to look at dilations that are centered at other points on the coordinate plane. So this one is centered at the point 7, 8. So I'm going to start by graphing that center. So 7, 8 would be right here. I'm going to write center next to it. So whenever I'm determining the distance, I'm always starting from the center and counting to the coordinate of the triangle. So let's start with point A. So just like I did in the video yesterday, I'm going to create some tables to help me with where A prime is located. So I'm going to start by counting from the center. Again, I always start at the center and count to point A. So to get from the center to A, it's left 1, 2, 3, 4, 5, 6. So left 6 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. So left 6, down 9. So again, the direction that I'm counting is starting at the center and going to point A. So for this example, the scale factor, the value of k is 1/3. So that means I need to multiply both of these distances, 6 and 9, by 1/3. Multiplying by 1/3 is the same as dividing by 3. So 6 divided by 3 is going to be 2. So left 2 for A prime, and 9 divided by 3 is 3. Okay, so I'm going to graph A prime. So again, I'm starting at the center. I'm going to go the same direction, but the distance has changed from A to A prime. So starting at the center, I'm going to go left 2, down 3. So this is the location of A prime. Let's take a look at B. So B is a little bit different. I don't have to go in two directions to get from the center to point B. I only have to move left. So B is left 1, 2, 3, 4, 5, 6, 7, 8, 9, which means B prime will also be left, but 1/3 of that distance. So it's just going to be left 3. So I go back to the center and count left 3. So this is my location for B prime. And then finally, C, the furthest one. So to get from the center to C, I'm going to go left and down. That's left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And down 1, 2, 3, 4, 5, 6, 7, 8, 9. So left, what did I say, 12, down 9. So for C prime, it will be the same direction. So if you want to write the direction again, you can, but it's just the same direction that it was initially over here. 1/3 of 12 is 4. 1/3 of 9 is 3. So I go back to the center and I count left 4, down 3. All right, so these are my 3 new vertices. Let's go ahead and connect them. Okay, so some things to check before we stop and decide that we're done with the dilation. Because K is less than 1, that means the new triangle should be smaller than the pre-image, which it is. My new little triangle here is smaller than the pre-image. It should also be closer to the center, so it should have moved toward the center, which it did. Remember, the shape stays the same when we do a dilation. So the original looked isosceles, so it had these 2 longer sides that are the same length and then a shorter side at the bottom. So I'm just going to check that that is also true in my new triangle. I have two kind of taller sides that are the same length, and then one shorter side at the bottom that's horizontal. These look like they're the same shape. It moved in the correct direction, and it is smaller than the original, so I'd say this looks like we did it correctly.